Hello everyone, I'm Zan Muhammad Abdul Haq and today we are reading Telangana State Syllabus 10th class Chapter 1 Reflection of Light at Curved Surfaces. Now we have already learned in the previous class some of the definitions related with curved mirrors. If you haven't seen the previous class, so the video's link is in description. You can check it out. In the previous class, we learned about center of curvature, radius of curvature, focal length, focus or the focal point, pole, the principal axis, etc. Now let us take a quick look at this flow chart here. Reflection happens through mirrors, and mirrors are of two types: plane mirrors, number 1 plane mirrors, number 2 spherical mirrors. Spherical mirrors are of two types: concave mirrors and convex mirrors. In concave mirrors, rays generally converge. They generally converge, and images formed are either real, inverted, either diminished or enlarged. And over here, between vertex and focus, if we keep an object, the rays diverge and the image formed is erect, virtual and enlarged. And in a convex mirror, rays always diverge and always virtual diminished image you will get. And over here, between vertex and focus, over here vertex meaning is pole. Now what is reflection of light? The process through which light rays fall on the surface and get bounced back is known as reflection of light. Like for example, if you bounce a ball on the floor, it comes back to you. Like that, if you see in a mirror, then the light rays of yourself will go near the mirror and bounce back and you can see yourself. Now the correct definition of the law of reflection defines that upon reflection from a smooth surface, the angle of reflected ray is equal to the angle of incident ray with respect to the normal to the surface, that is to a perpendicular to the surface at the point of contact. So over here, what is trying to say is that we know the simple thing that reflection happens on a smooth surface, alright, and the angle of the reflected ray is equal to the angle of the incident ray with respect to the normal. That means if we are measuring the angle from the normal to the surface, that is a line perpendicular to the surface at the point of contact. And here the reflected ray is always in the plane defined by the incident ray and the normal to the surface at the point of contact of the incident ray. The law of reflection is also defined as the principle when the light rays fall on smooth surface, the angle of reflection is equal to the angle of incidence. Also, the incident ray, the reflected ray and the normal all lie in the same plane. Now let me explain that. Let's take a plane mirror for better understanding. Let's draw our reflecting surface. Now see, if there is an incident ray going from right here, it's touching the mirror, and then the reflected ray is going there. Then let's draw the normal. So all of these are meeting at a single point on the mirror. Let's write our normal, incident ray, reflected ray. Now these all are meeting at a point right there on the mirror, this point, and they are in the same plane because this mirror is our plane, right? It is not like the incident rays in another plane and the reflected rays in another plane, the normal in another plane. No, it's not like that. These all are in one plane. Now this symbol here is our symbol for theta, and this one, this symbol, and over here this angle of incidence is equals to angle of reflection, it's saying here. Alright, so we know that, for example, we will take this angle 45, this will also be 45, right? The angles are equal, we know that. Everything clear? So now in the last video we learned that a curved mirror is the part of a sphere. If you haven't watched the video again, link is in description, you can go and watch it. So this red one here is our concave mirror, and its reflecting surface is inside, as you can see. And the blue one is our convex mirror, and its reflecting surface is outside. Alright? Now we will read more about concave mirrors. Concave mirrors give real inverted images if the object is beyond focus, and a virtual erect image, enlarged image, if the object has a distance less than the focal length from the pole of the mirror. That means if an object is kept beyond the focus, meaning behind the focus, it will give a real image, and a virtual image will be given when the object is kept more near to the mirror than the focal length. Which means if the object is kept between the pole and the focal point, then it will give a virtual image, and if it's kept beyond the focal point, then it will give a real image. Some uses of concave mirrors are: concave mirrors are used in torches, searchlights, and headlights of vehicles to get powerful parallel beams of light. Concave mirrors are also used as shaving mirrors to see a larger image of the face. Dentists use concave mirrors to see bigger images of the teeth of the patients. Large concave mirrors are used to focus sunlight to produce heat in solar furnaces. You might have learnt about a solar furnace or a solar cooker. It uses the rays of the sun and it concentrates it towards a small bowl, which becomes so hot that it can cook. Over here you can see the pictures of the examples. This is a concave mirror used by dentists to check the teeth of their patients, and this is a burning mirror. Don't confuse a burning mirror for a solar cooker, because a burning mirror in olden days was used to burn ships. They would concentrate sunlight and then use it to burn ships. And concave mirror in a torchlight, you might have seen it, and solar cooker and the headlight of a car. And now we will read about convex mirrors. Convex mirrors always give a virtual, erect, and diminished image behind the mirror, because virtual always means behind the mirror. Uses of convex mirrors are: the convex mirror is used as a side view mirror in vehicles to give a smaller view of vehicles coming from behind. You can have a smaller and wider view of vehicles coming from behind. And they are used in shops and supermarkets and any other place where there is a requirement for detecting burglars. Convex mirrors are also used in magnifying glasses and telescopes, and convex mirrors are also used in making lenses of sunglasses. Convex mirrors are used to reflect street light because they can reflect over a wide area. Convex mirrors are kept at street corners to avoid collisions. Now we'll see some examples of convex mirrors. So in this image we can see that light comes from the left side. That is the reflective surface. and inside this hard surface you can see the principal axis, the center of curvature which is 2f, 2 times the focus, and the focus capital F. This is a convex mirror. Convex mirrors are used in rear view mirrors, and they are also used in security mirrors, which are set in front of shops to see thieves. And you can also see them in parking lots. Those are traffic mirrors to see if anybody is not getting into your car, breaking your windows and stuff. And there is dome mirror, which is in shops, automobile side mirror, which you can use in cars, ATM convex mirror. You can find this in most of the ATMs. You can see behind you that there is like no one coming behind you with a knife. And wall art decoration, this is even for decoration, and this is even used for undercar inspection. This is also an education application, and there are many more uses. Before we end this video, I want to say you that if you want the notes in this video, then you can go in the link in description. There I have uploaded this as a PDF, so you can write your notes. If you like this video, like, share and subscribe to the channel for more videos. And don't forget to click the bell icon so that you get updated with every video we post.